Elon Musk's ambitious Mars colonization plan, outlined in 2016, centers on a revolutionary interplanetary transport system, Starship. This audacious vision, aiming for a self-sufficient Martian colony, involves a massive rocket designed for transporting large groups of colonists. Musk's initial inspiration for the Mars project traces back to 2001, when the concept was more focused on establishing a greenhouse on the red planet. However, this initial plan evolved into a more comprehensive approach to human settlement. The current plan underscores the profound shift from a research project to a full-scale human endeavor to create a new home for humanity beyond Earth. The detailed framework, while ambitious, lays out a multifaceted strategy for establishing a presence on Mars, requiring substantial technological advancements. Initial stages involve developing the Starship transportation system, a monumental undertaking involving the creation of a powerful rocket capable of ferrying large groups of people and resources to the Martian surface. The plan outlines a phased approach, starting with uncrewed missions before gradually introducing crewed flights. This phased approach underscores the immense complexity and long-term commitment involved in the colonization endeavor. SpaceX's Starship program, launched in 2019, has made significant progress toward enabling a human presence on Mars. Successful test launches and controlled landings of the Super Heavy booster and Starship upper stage in recent years mark crucial milestones in the ambitious endeavor. Elon Musk expresses confidence that uncrewed Starship missions to Mars will occur within 2 years, paving the way for crewed missions to follow within 4. This aggressive timeline highlights SpaceX's commitment to rapidly advancing the technology necessary for such a monumental undertaking. The possibility of initial setbacks is acknowledged, presenting potential challenges, but the project is moving forward at an accelerated pace. Key developments include the significant engineering achievements and the demonstration of Starship's capabilities for interplanetary travel. The program is testing the rocket's ability to perform controlled landings both on Earth and in preparation for the more challenging Martian landscape. These initial tests are laying the groundwork for a potentially historic first landing on Mars, paving the way for the first steps in establishing a human presence on the red planet. Musk's Mars colonization plan integrates resources across various SpaceX companies. Tesla's Cybertruck and Optimus robots are crucial for initial Martian settlement and infrastructure development, tackling tasks from construction to resource gathering. The humanoid Optimus robot, a key component, will facilitate early settlement by performing crucial tasks and establishing basic infrastructure for future human arrival. This reliance on advanced automation and artificial intelligence is vital for ensuring survival in the harsh Martian environment. The plan underscores the integration of diverse technologies and approaches for the establishment of a sustainable presence on Mars. These elements form a crucial part of the overall colonization strategy, showcasing Musk's ambition to utilize existing and newly developed technologies to overcome the significant challenges of creating a thriving Martian community. Elon Musk acknowledges the inherent dangers of a Mars mission, emphasizing the risks involved in such a long-duration journey. His vision focuses on creating a self-sustaining Martian city, requiring substantial resources and a phased approach to logistics. Thousands of Starship rockets are envisioned to transport supplies and materials from Earth. This massive logistical undertaking underscores the scale and complexity of the colonization project. The plan highlights the need for comprehensive preparation and resilience to ensure survival and establishment of a permanent presence. This includes robust contingency plans for resource management and technological safeguards. The need for meticulous planning and foresight for maintaining a self-sufficient colony is central to the Mars colonization vision. The significant risk is recognized, but the focus is on developing and implementing measures for ensuring long-term survival and creating a functional Martian settlement. Musk's plan extends beyond basic survival, encompassing technological advancements to enhance Martian life. A large language model, GROW, is envisioned as an artificial general intelligence, a crucial resource for settlers facing communication delays with Earth. Neuralink, a brain-computer interface, is another key element, aiming to connect human minds with AI for remote operations and knowledge access. This integration of advanced technologies is seen as critical for overcoming the challenges of a remote, isolated settlement on Mars. These advancements represent a significant leap forward in technology, aiming to mitigate the isolation and logistical constraints of a distant human colony. The potential benefits extend beyond simple survival, emphasizing the enhancement of life and communication for those establishing a new society on the Red Planet. This integration of technology is vital for creating a viable and sustainable long-term human presence. A self-sufficient Martian colony, potentially housing 1 million inhabitants, is a central component of Musk's plan. This ambitious goal necessitates the transport of vast quantities of supplies and materials from Earth, a complex logistical undertaking. Thousands of Starship rockets are envisioned to deliver the necessary resources. The scale of this task underscores the significant effort required for long-term Martian settlement. The focus is on establishing a functional base that can support a large population, a vital component for sustainable habitation on the Red Planet. The logistical challenges highlight the immense complexity of establishing a self-sustaining human presence. Detailed planning and resource management are critical elements of this stage of the colonization process, necessary to ensure the viability and long-term success of such a large-scale endeavor. This underscores the extensive preparations needed for a potential future human settlement on Mars. Musk's plan addresses the harsh Martian environment, focusing on creating sustainable habitats. Underground habitats, protected from radiation, dust storms, and micrometeoroids, are a key element in this strategy. This approach mirrors the use of underground shelters in science fiction depictions of Martian settlements. The design and construction of these underground settlements are vital for mitigating the harsh conditions of the Red Planet. The plan anticipates that building underground shelters will be crucial for protecting inhabitants from Martian hazards, especially given the prevalence of dust storms and the radiation environment. This element is a key part of the long-term sustainability strategy, aiming to provide essential protection and support for Martian colonists. The focus on underground infrastructure reflects the challenging realities of establishing a lasting presence on Mars. The question of governance for a Martian colony, a potential city of 1 million, is a significant yet unanswered aspect of Musk's plan. The necessity for a legal system, leadership structure, and a functioning constitution is crucial for a sustainable society. This aspect of the plan, while present in the vision, lacks specific details. The complexities of establishing and maintaining a Martian government, especially given the isolation, are apparent. The absence of detailed governance plans raises questions about how a potentially large and isolated Martian community would manage itself. This crucial element of long-term sustainability on Mars requires further consideration and definition. It underscores the vast array of complex issues that must be addressed for a successful Martian colony. Elon Musk calls for International Space Station to be deorbited by 2027. SpaceX boss Elon Musk has called for the International Space Station, ISS, to be deorbited as soon as possible, perhaps by 2027. Yesterday, Musk tweeted on his social media mouthpiece X that it is time to begin preparations for deorbiting the space station. He claimed the outpost had served its purpose and there is very little incremental utility. Later, the billionaire, who also leads DOGE, an organization charged with improving the efficiency of the U.S. government, said, "I recommend 2 years from now." The ISS is aging, and before Musk's intervention, the plan was to deorbit it in 2030. SpaceX was awarded a contract in 2024 worth almost $1 billion to do the deed, but will need to work fast if Musk's suggestion is accepted by the U.S. President Donald Trump. The original plan required a deorbit vehicle to be ready by 2029. Musk's statement comes as the U.S. space agency NASA is going through a period of uncertainty. Budget worries, job cuts, and the prospect of SpaceX customer Jared Isaacman being its administrator weigh heavily on the agency. Therefore, the possibility of an axe falling on a flagship program such as the ISS will be unwelcome. NASA's international partners, such as the European Space Agency, ESA, expect the ISS to remain in orbit until 2030 or beyond. Russia has committed to keeping the ISS going until 2028. The Register asked ESA for its thoughts on the matter, and a spokesperson said, "The International Space Station is a project involving various international partners. As such, all matters regarding the ISS are discussed together with all space agencies involved." An early end to the ISS also has commercial implications. Several private companies have plans for stations in low Earth orbit, but even the most optimistic timeline won't result in a standalone station before 2028. Unless, of course, SpaceX manages to get some starships into orbit to replicate some of the utility of the ISS. The ISS is hitting its stride in terms of utilization. The station typically has at least 7 crew members on board. The number fluctuates during crew rotations using the 3-person Soyuz and 4-person Crew Dragon spacecraft. There are, therefore, resources available for research as well as maintaining the outpost itself. As such, an earlier-than-planned ditching would be a waste. Taken at face value, Musk's desire to get to Mars appears to be the driving factor. His company SpaceX already has lucrative contracts to keep the ISS supplied with crew and cargo. An early end to the ISS would mean no further contracts, yet it would also free up resources to fund a human mission to Mars. However, ESA's comments that the fate of the ISS is something upon which all international partners must agree, as well as the need to get U.S. lawmakers to give the plan the green light, indicates that just tweeting something does not necessarily make it policy.